Okay, so video 2, let's look at another situation, which is motion on a line. And what we're dealing with here really is particle motion. Imagine a line and you've got some particle and it starts right here and it moves. And it could move left, it could move right, but it can't move up or down. It's only going back and forth. So we're looking at S of 0, where S is position. Um, and that will be fairly standard. Anytime you see S, you'll be thinking position, which is a function of time. And if we are at time t here, maybe we don't call this S of 0. Maybe we call this S of t, some time t. And at some other time t plus delta t, we have a different position. And of course, we can think of the change in position as being, where was I when I finished, minus where was I when I started. And this is fairly important. This is pretty key here. Routinely, students forget to subtract that starting position when they're dealing with these kinds of problems. So what do we got here? Well, my average velocity, if I'm thinking about position, is, of course, my change in position over change in time. And we could write that out as a difference quotient of position at the final time minus position at the initial time divided by the change in time. And of course, my instantaneous velocity, this is what you see on the speedometer of your car as you're driving down the road, is just the limit as delta t goes to 0 of that difference quotient. So, let's look at a quick example. This is a graphical example, velocity of a race car. And I'll try to do this fairly quickly. We've got some graph that shows how fast a race car is going. Here's some point P at time T. Well, let's say that's at time 2. We've got some other point Q at time 5. The average velocity is that right there. The average velocity is the slope of the secant. The instantaneous velocity is the slope of the tangent line. And so when we're thinking about this, we just keep moving Q. If we just keep moving Q closer and closer and closer to P, we'll eventually get that limit. Go ahead and do exercise 7. I'll let you pause for just a second to go off and do exercise 7. All right, and then the last thing we need to know, the last definition, is we need to understand that speed is equal to the absolute of velocity. Speed doesn't care about direction. Velocity has direction, so this is why you have a speedometer instead of a velocitometer, I don't know, whatever you would call it, speedometer, velocityometer, because your speedometer doesn't tell you whether you're going north, south, east, west. It honestly doesn't care. So we can then calculate speed as in just how fast am I going. Okay, we will stop there and we will come back with the next thing in video 3. Thank you.